हेलो फ्रेंड्स, गुड मॉर्निंग। आज हम पढ़ने वाले हैं नेक्स्ट टॉपिक। इससे पहले हमने हिट बजट और कुछ टॉपिक से रिलेटेड टू कि कैसे मॉडिफिकेशंस होते हैं, अनबैलेंस होते हैं हिट बजट, ये सारी चीज़ें हमने देखी थी। ठीक है, अब हम आज देखने वाले हैं, आज जो मेन टॉपिक होगा हमारा, ये 3 तरीके का टॉपिक होगा, जिसमें पहला हम देखेंगे टेम्परेचर पैटर्न अकॉर्डिंग टू आइसोथर्म, एक देखेंगे हम प्रेशर बेल्ट का डिस्ट्रीब्यूशन अकॉर्डिंग टू लैटिट्यूडनल एंड मेरिडियनल पैटर्न, ये दोनों देखेंगे। साथ ही साथ जो तीसरा टॉपिक होगा जिसमें हम टेम्परेचर इन्वर्जन के बारे में पढ़ने वाले हैं, या फिर इन्वर्जन ऑफ टेम्परेचर, जिसको थर्मल इन्वर्जन के नाम से भी जाना जाता है। एक और छोटा सा टॉपिक होगा जो कि एनोमैलस टेम्परेचर इसको कहा जाता है। ठीक है, जिसमें हम एनोमैलस टेम्परेचर के बारे में पढ़ते हैं। तो यहाँ पर आपको 3 क्वेश्चंस देखने को मिलेंगे, जो कि दो सेम क्वेश्चन आए हुए हैं, इन्वर्जन ऑफ टेम्परेचर एंड इन्वर्जन ऑफ टेम्परेचर, ये 1995 और 2010 में। ठीक है, और एक क्वेश्चन आया है 2016 में, डिफरेंशियल बिटवीन द इंसुलेशन एंड टेम्परेचर एंड एक्सप्लेन एनोमैलस टेम्परेचर। ओके, you know about temperature actually it is a degree of coldness or hotness, but the insolation is incoming solar radiations of short wavelength. Okay, and you can also write some spectrum, light spectrum like gamma rays, x-rays, UV light, visible light, x-ray, infrared, okay, and so on. So you know about insolation and temperature. Now today class we also learned about anomalous temperature. It is called anomalous. Okay, so after today class you will be able to write these questions. Okay, now the first topic we are going to take today is temperature pattern according to isotherm. You know about isotherm. Isotherm is a line which joins equal temperature on globe. Okay, isotherm is a line which joins equal temperature on globe. You have read it in GS also, GS geography, in NCERTs also. Okay, so it is not a new term. Now we'll study about the temperature pattern according to isotherm. Okay, now some things you have to write at first, then I will discuss step by step with points. Okay, write down something. First point, isotherms. First point, isotherms are line joining places of equal temperature. Isotherms are line joining places of equal temperature. The assumption, full stop. After that, the assumption is reduced. The assumption is reduced to sea level. Means we will consider the isotherm or temperature pattern at sea level. Okay, that's why isotherm does not depict the actual temperature of that place. That's why isotherm does not depict the actual temperature of that place. Okay, I'm repeating again. Isotherms are line joining same temperature places or equal temperatures places on globe. The assumption is reduced to sea level. That's why isotherm does not depict the actual temperature of that particular region. Write down next point, second one. Okay, this one first point, second one. Because of fundamental control of temperature, because of fundamental control of temperature is insolation which varies latitudinally, comma, the isotherm is also trained east-west parallel to the latitude. The isotherm is also trend, T-R-E-N-D, trend east-west parallel to latitude. ठीक है, देखिए isotherms are line joining of same temperature on a particular place. Now it does not depict the actual temperature of that place. Why? Because the temperature assumption is reduced at sea level, and at sea level you will find approx more or less same temperature across same latitude. For example, this is continent, and this is sea area. Okay, if you draw the isotherm on the sea surface, this isotherm will be not the same on the land, okay, as on the ocean, because the temperature of water or the temperature of land is different on the same latitude because of differential heating. That's why if we are assuming the isotherm at the sea level, that means we are not considering the temperature on landmass. That's why this isotherm will not depict the actual temperature of that area or of that latitude. Okay. Now the second point is that because of fundamental control of temperature is insolation, which varies latitudinally. That's why isotherm will trend east to west parallel to the latitude. Okay. That means the fundamental source of energy is what? Sunlight, insolation, and that insolation varies latitudinally, okay, according to latitude. That's why the isotherms are also parallel to that latitude from east to west or west to east, according like this. These are isotherms parallel to latitude. Why? Because insolation varies according to latitudes. Okay. Now the third point, note down. Third point, the modification and the anomalous, the modification and anomalous pattern, the modification and anomalous pattern is obvious, obvious, obvious by the fact isotherm is not a smooth straight line. By the fact isotherm is not a smooth straight line. What does it mean? The modification and its anomalous temperature. Its anomalous temperature means the anomalies in temperature, means the differences in temperature. We will study about the anomalous pattern. Okay, here just understand it is talking about anomaly in temperature. Anomaly in temperature means the difference between the actual temperature and the mean temperature. Okay, so according to this anomalous pattern, the isotherms are not a straight line because it differs the temperature in ocean and the temperature of land. Okay, next point, fourth point is the northern hemisphere being the land hemisphere, the northern hemisphere being the land hemisphere will have more irregular isotherm, and will have close spacing between isotherms, whereas the water hemisphere means southern hemisphere, okay, will have more even and more smooth isotherm. Why? Because whereas the water hemisphere or southern hemisphere will have more even and more smooth isotherm. because in southern hemisphere you will find less land, okay, and more water. So there will be the exact pattern, or there will be the approx more or less same pattern of isotherm. There will be not much difference in the temperature in southern hemisphere because the absence of land. Okay, much of the land concentration is in northern hemisphere. That's why due to the differential heating, okay, the heating pattern of water and heating pattern of land, okay, both are different. So due to the differential heating, the temperature anomaly or anomalous pattern is different. Okay, so in northern hemisphere, due to the land mass, the isotherms are very irregular and close spacing. Okay, but in southern hemisphere, due to the availability of lot of water, the isotherm will be smooth, more or less, and even. Also, next point, fifth point, write down. With the apparent movement of sunlight, with the apparent movement of sunlight, the isotherms will also shift. The isotherm will also shift and migrate north and south. I will repeat. With the apparent movement of sunlight, the isotherm will also shift and migrate north and south. Full stop. Shifting of isotherm is real. Shifting of isotherm is real. Okay, write down in this point, in fifth point as well. Differential heating of land and water. Differential heating of land and water in summer on land. Differential heating of land and water in summer on land, isotherm will shift poleward. Isotherm will shift poleward, and in winters on the land will shift equatorward. And in winters on the land will shift equatorward. What does it mean? Okay, this is Earth, this is equator, and this is land mass. Okay, now in summer season, considering we are summer season, and here is the water surface and this is the continent, this one is the continent. You know, the heating process of continent and water is different. That's why the differential temperature will be different. Okay, for example, suppose water is heating at the rate of 5 degrees Celsius or whatever, the temperature of water is 10 degrees Celsius in this particular region. What will be the temperature of land on the same latitude? If this is a latitude called 10 degree, for example, 10 degree, and the temperature of water at 10 degree latitude is 10 degrees Celsius, then what will the temperature of land at this latitude? It will be more than 10 degrees Celsius, you know, because land will be warm at a very high speed, at a very high rate than the water. That's why the same latitude, the temperature of that land or that particular area on land will be more than the temperature of water. Okay, maybe the temperature of the land is here maybe 15 degrees Celsius. Okay, this is 15 degrees Celsius. Okay, and 10 degree will be poleward, because poleward the temperature will decrease. That's why the less temperature on land will be poleward. Now the isotherm, a line which joins the same temperature on the globe, will be like 10 degrees Celsius, then this will be 10 degrees Celsius, like this, then this. Here you will see there is a curve poleward on this land. That means in summer season on land, the isotherm shift poleward. Okay, and in the opposite thing, in winter season, the isotherm will shift equatorward. Okay, I hope you will get it. Fine. Write down next point. Although the general trend in poleward is cooling, although the general trend in polewards is cooling, but equator is not the warmest latitude. But equator is not the warmest latitude. ठीक है, वैसे when you will move towards pole, the temperature will decrease, but that does not mean the equator is a warmest place or warmest latitude. Why? Because, write down next, because warmest place, because first point, dense thick cumulonimbus cloud. First point, because first point, dense thick cumulonimbus cloud, they block insolation. And the second point, upwelling along equator of cold deep water of the ocean. Upwelling along equator of cold deep water of the ocean. Okay, in bracket you can write it is called Ekman transport. It is called Ekman transport. Okay, next in note you can write a sentence where the subtropical latitude have highest temperature. Subtropical latitude have highest temperature due to stable condition, sinking air and inhabited clouds formation. Okay, due to stable conditions, sinking air and inhabited cloud formation. So the maximum temperature will be at tropics, not at equator. Okay, now this is the end of this topic, pattern of global temperature or pattern of temperature depicted through isotherm. Fine. Now the next topic we will study is now thermal inversion or inversion of temperature. Inversion of temperature. ठीक है? Now the inversion of temperature means, what does it mean? You have read in GS paper also, in NCERTs and all these things. Inversion of temperature means the condition where the normal phenomena or normal condition is not followed. For example, in normal conditions, when the altitude or height will increase, the temperature will decrease in normal conditions. In normal condition, what happens? Height will increase and temperature will decrease with increase in height. It is also called normal lapse rate in troposphere. But the opposite of this normal condition, what will be happen? With increase in height, the temperature will also increase. Okay, and this situation is called thermal inversion or inversion of temperature. Okay, thermal inversion, you can say thermal inversion. Okay, when this situation will not follow the normal condition and will be opposite to the normal condition, so in this situation, with increase in height, the temperature will also increase. So this situation is called the inversion of temperature. This type of situation will also find at Earth's surface, and this type of situation will also found at aloft condition. Aloft condition. This is aloft condition. Aloft condition means upper atmosphere. Okay, like in stratosphere. In stratosphere, you will find ozone layer, and ozone layer, you can say, ozone layer absorbs ultraviolet radiations. Due to this layer will be heated up. Okay, stratosphere. So we'll find the stratosphere, this layer is up to the troposphere, and troposphere will be cold in compared to stratosphere. This will create the inversion of temperature. Means the lower layer will have the cool air, and above that cool air you will find the warm air. Means with increase in height, temperature is increasing. That's why you are seeing here the warm air above the cool layers. Okay, this situation is called inversion of temperature. Okay, now the some questions about the inversion of temperature in different years, like in 1995 and 2010. Very simple question: what is inversion of temperature, or short note an inversion of temperature? Maybe 150 watts. Okay, so you should have some points or some materials to write about the inversion of temperature. Okay, now write down some points. First one, you can write height will increase with temperature will increase, and this is called actually negative lapse rate. This is called negative lapse rate. Okay, this is the first point, and this is called the thermal inversion. Second, why negative lapse rate? Because it is opposite to the lapse rate. In troposphere, you will find the temperature will decrease with increase in height at the rate of 6.5 degrees Celsius per kilometer. But in stratosphere, you will find the negative lapse rate, means that temperature will increase with increase in height. Okay, that's why it is negative lapse rate. Second point, write down: such situation may occur near the Earth's surface. Such situation may occur near the Earth's surface or at greater height in troposphere, but inversion of temperature near the Earth's surface, but inversion of temperature near the Earth's surface is of very short duration. Is of very short duration, because radiation of heat from Earth's surface during daytime warms up the cold air layer. Okay, at the Earth's surface, this is the Earth's surface, this thermal inversion will be of short duration because of the insolation. In daytime, due to the insolation will be heat up, but after the daytime this insolation is disappeared, and again it will be in normal condition. That's why in daytime it will be of short duration at the point of surface of Earth. Next point, third one, upper air temperature inversion upper air temperature inversion lasts for longer duration. Lasts for longer duration because the warming of cold air layer cold air layer aloft means upper troposphere. Okay, warming of cold air layer aloft through terrestrial radiation takes relatively longer period of time. Takes relatively longer period of time. Takes relatively longer period of time means in upper atmosphere, like in stratosphere, the heating of air may be due to the terrestrial radiations, and this will be hit up in a longer period of time. That's why the thermal inversion in upper atmosphere, like in upper troposphere or lower stratosphere, it will be of longer duration of time. Okay, now these are some points about the inversion of temperature. Now we will study something about the types of inversion of temperature. The next topic will be types of inversion of temperature. Here we will study about the two types of inversion of temperature. One is non-advectional inversion of temperature, and second is of advectional inversion of temperature. In non-advectional, we will study about the two things. First is surface, or you can say ground, or radiation inversion. Radiation inversion means a non-advectional inversion of temperature has two subtypes. First one is surface or ground or radiation inversion, and second one is upper air non-advectional inversion. Okay, upper air non-advectional inversion. And in advectional, it will have three subtypes. One is frontal or cyclonic advectional inversion. Second one is mountain valleys or valleys, you can say, or vertical advectional inversion. And third one is surface inversion or surface advectional inversion. Okay, so mainly we are going to study about these five types. This one, second, 3, 4 and 5. Okay, 2-3 points only, not too much. Okay, now the first one is surface or ground inversion or non-advectional inversion. It is also called radiational inversion. Okay, here some conditions for the development of this type of surface or ground thermal inversion. Actually, this surface or ground thermal inversion is occur at the surface of the earth. It will be at surface of earth. That's why it is called surface or ground thermal inversion. Okay, now here are some conditions for the development of surface or ground thermal inversion. First one is, you can write simultaneously. First one is longer winter nights. Second is cloudless and clear sky. Third, less air movement. Okay. Fifth one, dry surface air. And fifth one, snow covered area. Snow covered area. Less winter nights, longer winter nights means more loss of heat through radiation, through terrestrial radiation, you can say. Terrestrial radiation. Again, the same thing here will be happen. Less air movement means less mixing of air. Dry surface air means less absorption of temperature, or insolation means less temperature. That means, okay. And snow covered area means more reflection. More reflection means less absorption, means less temperature. Okay, so these are the conditions, 5 conditions actually, which are helpful in the development of surface or ground non-advectional temperature. It's a inversion of temperature. Okay, now next one, second, is upper air inversion. In upper air inversion, it will be happen when there will be no any vertical movement of air. It will be happen only when no vertical air movement. No vertical air movement. Okay. Upper air inversion, you can say about the stratosphere. Stratosphere, heating by UV lights. Okay. Now this is the upper air inversion, you can say. Third one is now the time of advectional inversion. Third one is called frontal or cyclonic. Frontal or cyclonic inversion. It will be in temperate zones. It will be in temperate zone at the time of temperate cyclone. At time of temperate cyclone. Okay. Fourth one is valley inversion. Valley inversion, like in mountain areas. For example, this is the mountain valley, this is the mountain upper part, and this is the valley. Okay. In mountain upper part, this area, in winter season, there will be terrestrial radiation, so more heat loss. More heat loss means the temperature will be less. Okay, and when temperature will be less, the air will be heavy. Okay, but at the valley side, this area here, the rate of cooling or the rate of terrestrial radiation or rate of heat loss will be less than the upper part of mountain. Here in valley, the rate of heat loss will be less than upper part of mountain. That's why the temperature will be more. Temperature will be more means air will be light. Okay. So now the air which is heavy at this upper part will descend here towards valley, and it will push the light air or warm air, comparatively warm air, upward. Okay, so in this situation, the cold air will be within the warm air. This is the warm air. Okay, and this again will create the condition of inversion of temperature. Okay, so this is called the Wallis inversion of temperature. Here you will see the movement of air in vertical direction. Vertical directions. That's why it is also called the vertical thermal inversion, Wallis. Now the fifth one and last one is the surface thermal inversion due to horizontal movement of air. Okay, surface thermal inversion due to horizontal movement of air. In this thing, you will see the different types of conditions. For example, when warm air active and invades in cold air area, okay, this condition will be on different locations, like on continents it will be in winter season, and on ocean it will be in summer season, this condition. Okay, and the opposite is when cold air active and invades in warm air area. This situation will be in different seasons. On continents it will be in summer, okay, but on ocean it will be in winters. Okay, generally this type of situation will be in low latitude. Generally in low latitude this situation will be. Okay, so you can write these are things in the questions which have mentioned above, which came here, the inversion of temperature. You can write the definition of inversion of temperature and also the types of inversion of temperature, and this is the enough for this content. Okay, now this is about the inversion of temperature. Now the next point we are going to study about is the horizontal distribution of air pressure. Horizontal distribution of air pressure and pressure belt. Okay. Next topic will be horizontal distribution of air pressure and pressure belt. In this we will study about two things: the latitudinal distribution of pressure and meridional, yani ki longitudinal distribution of temperature. Pressure, not temperature. Okay. Now, the first thing we will write here, the latitudinal distribution of pressure, distribution of pressure. Okay, like this is 0 degree, this is 30 degree, this is again 30 degree, this one 60 degree, and this is 90, and here 60 degree, and here 90. Okay, 0 degrees area of low pressure, and this is high pressure. Again this low pressure and this is high pressure. Okay, this is high 30 degree and this is 60 low pressure and this is 90 high pressure. Okay, These are the latitudinal distribution of pressure actually. Okay, so in words you can also write equatorial low pressure belt. Then you can write subtropical high pressure belt. Then you can write a subpolar low pressure belt, and fourth one is polar high pressure belt. Okay, this is the latitudinal distribution of pressure. Okay, fine. Have you written? Do fast. And actually you know all about these things. What is equatorial low pressure and why this is low pressure and why this is high and low, you know. Actually the equatorial low pressure and the polar high pressure, these two pressure belts are thermally induced pressures belt. Okay, which one? Equatorial low pressure, it is thermally induced pressure belt. As well, this is the polar high pressure is also thermally induced pressure belt, both in northern and southern hemisphere as well. And these two pressure belts, this is the subtropical high pressure and subpolar low pressure, these two pressure belts are dynamically induced pressure belts. Dynamically induced pressure belt. Dynamically induced pressure belts means these pressure belts are according to the rotation of Earth. Okay, but the 90-degree high pressure or 0-degree low pressure are thermally induced, means according to the insolation pattern. And you can add all these things also in bracket in figure. The same pattern will follow in southern hemisphere also. In southern hemisphere also 90-degree high pressure is the thermally induced, and 60-degree high pressure and 60-degree low pressure and 30-degree high pressure is dynamically induced pressure belts. Okay, so let's move next. Second is meridional distribution of pressure belt. Meridional means longitudinal, you know, longitude is also called meridian. So meridional distribution of pressure belt is actually longitudinal distribution of pressure belt. What is meridional distribution? It is average seasonal sea pressure for all longitudes. Okay? It is average seasonal sea pressure or sea level pressure for all longitudes. Now we'll write something here. In here, first point, three type of pressure belts you will find in the meridional distribution. Three types of pressure belts. Okay, first one is equatorial low pressure. Second one is subtropical high pressure, and third one is subpolar low pressure. Okay, in meridional distribution you will find three types of pressure belts. One is equatorial low pressure, subtropical high pressure, and third one is subpolar low pressure. लिखने की स्पीड को बढ़ाइए. Increase your writing speed. Second point is that the seasonal shifting of pressure belt. You have read about this. The seasonal shifting of pressure belt according to the seasons. You know, like in a summer season or winter season, you will find. You will write here the seasonal shifting of pressure belts. Seasonal shifting of pressure belts becomes effective during summer and winters, becomes effective during summer and winters. In summer season and winter season, in both, the pressure belt will follow the temperature distribution, and temperature distribution will follow the apparent movement of sunlight. Okay. Next point, third point. Subpolar low pressure in southern hemisphere. Subpolar low pressure in southern hemisphere. Subpolar low pressure in साउदर्न हेमिस्फेयर. लो प्रेशर को एलपी से, हाई प्रेशर के एचपी से ऐसे शॉर्ट में लिखा कीजिए, बहुत पूरा मत लिखिए. सबपोलर लो प्रेशर इन साउदर्न हेमिस्फेयर इज वेरी लो. ब्रैकेट में लिखिएगा अप्रॉक्स 990 MB मिलीबार. इज वेरी लो इन ब्रैकेट अप्रॉक्स 990 MB and is more or less stable during summer and winter seasons. And is more or less stable during summer and winter seasons. But northern hemisphere को HEMIS बस इतना ही लिखिए, पूरा लिखने की जरूरत, समझ नहीं जाएंगे आप, बार बार लिखते हैं. Northern hemisphere subpolar low pressure. In northern hemisphere subpolar low pressure ranges between 1008 MB to 1015 MB. Means the pressure value will be more in northern hemisphere than the southern hemisphere. Okay, you have to write these values 990 or the range of this in exam. Okay, it will provide you value addition in your answer. Next point we'll write, fourth one, pressure gradients are very steeper. Pressure gradients are very steeper in winter than in summer. Okay, gradient means slope, or it is the difference, you can say pressure difference or pressure gradient are more steeper in winters than in summer. Next point, fifth point, right? Enormous mass transfer of atmosphere. Enormous mass transfer of atmosphere. Atmosphere को बस 80 से लिखा कीजिए. Transfer atmosphere in bracket air circulation. In bracket air circulation from warmer summer hemisphere to colder winter hemisphere. ठीक है. So this is the meridional distribution of temperature. Fine. Now the next topic we are going to cover is anomalous temperature. The next topic is anomalous temperature. Okay. Anomalous means actually anomaly of temperature. means the difference of temperature. We'll see this thing. Okay, write down actually the definition of anomalous temperature. According to, write down, according to Oliver, according to Oliver, Oliver, and Hidor, according to Oliver और Hidor का स्पेलिंग आपको कहीं HIDORE में भी मिलेगा, ठीक है. According to Oliver and Hidor, they were geographers, so you have to write name of geographers whenever required. According to Oliver and Hidor, anomalous temperature as anomalies which represent deviation from temperature that would only result from solar energy, ठीक है, which represent deviation from temperature that would only result from solar energy. Okay, this is the anomaly actually. So you can write thermal anomaly. Thermal anomaly is equal to observation or observed temperature, you can say observed temperature minus mean temperature of that area, The difference is called the thermal anomaly, and this is the anomalous temperature. Okay, when there will be warm condition, for example, take an example. Okay, suppose in Delhi the mean temperature of Delhi may be, for example, it is 30 degree. This is suppose, it is not the exact data, I am giving one example. 30 degrees Celsius, this is the mean temperature. Okay, and in summer season, actually you will find the temperature in Delhi will be more than 40 degrees Celsius. For example, take the 40 degrees Celsius. In winter season, you will find the temperature 4 degrees Celsius or sometimes 2 degrees Celsius also. Let's take an example of 10 degrees Celsius in winter season, and this is in summer season. And this is the mean temperature. When you will minus in summer season, there will be positive value. This is the 40 degree and this is the 30 degree. This is the positive value. Positive value means the warmer condition. That means this is the summer season. And we will minus this 10 degree and this 30 degrees Celsius, there will be negative value. That means negative value means the winter season. Okay. So, what does it mean? The positive anomaly means the warmer condition, and the negative anomaly means the colder condition. It may be due to any reasons, also it may be in the area of oceanic currents. Due to warm oceanic currents, there will be warm condition, positive anomaly. Due to colder oceanic current, due to will be negative anomaly in colder conditions. Okay, and it will be also according to latitude distribution, or also according to altitude. When increase in height, the temperature will decrease. Okay, so this is the positive and positive anomaly and negative anomaly. Now, write 2 points here, not more, only 2 points. First point: equal thermal anomaly of several places. Equal thermal anomaly of several places is called anomalous temperature. Equal thermal anomaly of several places is called anomalous temperature. And the isolines drawn on world map, isolines drawn on world map joining places of equal thermal anomaly are called isonomals, means like isobars or like isotherms. Okay, this is also isonomalous. This isonomalous actually the line with joining the same temperature anomaly areas. Okay, anomalous. Second point, it is part of horizontal distribution of temperature. It is part of horizontal distribution of temperature wherein temperature difference is more emphasized. Okay, these are 2 points we'll write in is anomalous temperature. So now the topics of today topics are actually completed. Now visit this question. These are thermal inversion. We have studied this. Now this is the anomalous temperature. You have to write about the anomalous temperature here. Okay, so you have enough points to write about this anomalous or anomalous temperature. Okay, now we'll write about these questions. About this question you will post answer in Telegram group. I hope you will post, but I know you will not post. Okay, I know very much will not post. Now see, it is up to you how you want to prepare or not actually. Okay, now so here we'll study about the horizontal distribution of temperature according to isotherms, horizontal distribution of pressure belts also, and thermal inversion also, and its anomalous temperature also. So we have studied about the 4 points. Revise it before the next class. In next class we'll start the atmospheric circulation. Okay, in next class we'll start the atmospheric circulation and some theories given by different geographers, climatologists. Okay, we'll study about them. Okay, so now thank you and good luck.